Hey guys, in this video we are going to discuss what dictionaries or hash tables are, right? So before starting our code implementation, let us have a quick overview about what dictionaries are, right? So we are using Python language, so we are going to understand in terms of dictionaries. So dictionaries are one of the inbuilt data structures in Python in which our data is stored in the form of key value pairs, right? So there will be a unique key to every value stored in our data sequence, right? So as you can see, I have declared my dictionary which has three entries. So there are three keys: Samaksh, Anand and Aditya, and there are their respective data or values associated with these keys. So Samaksh key has 24 integer value, Anand has 25, Aditya has 26. So if we want to print out this dictionary, okay, so we want to just print it. So as you can see, Samaksh, Anand and Aditya has been printed. Okay. Now, if we want to print my dictionary, let's say get, so there is a get function, and if we write Anand, okay, so it should return the value associated with Anand, right? So 25. Okay. And if we my dictionary dot pop, so let's say we want to pop out Samaksh, okay, and we print out our dictionary again. So as you can see, Samaksh has been popped out. Okay. So now I think this is clear to you all, and let's start our implementation of this data structure. We want to create a hash table or a dictionary. Okay. So let us go through these points which I have mentioned. So data is stored in key value pairs. Okay. So the underlying data structure which we are going to use in this implementation will be an array or a Python list. Okay. So to make the algorithm fast, to make the processes of insertion, deletion faster, like we want it to be of time complexity of order of 1 or constant time complexity, so we are going to use the indexing property of arrays or lists. Now for accomplishing constant time complexity, we have to define a hash function. Okay, hash function is a function which maps keys to array indexes in the array to be able to use random indexing and achieve order 1 running time. Basically, the hash function returns the index value where the data should be placed. Right now, in the fifth point, I have mentioned about collisions. Okay, so collisions occurs when the hash function maps two keys at the same array slot. So it may happen that two keys have the same index value. So we want to do something about the collision. So we want to avoid collisions. But in reality, there are it's very rare to find ideal hash functions, as functions can be better, but they are not ideal. So at some point, they may end up giving collisions. Okay, so we have certain ways of dealing with collisions, right? So in the point 6, I have mentioned chaining and open addressing. Okay, so chaining is a different topic, and I'll not be covering this chaining method in this video. I'll be covering open addressing in this video. Okay, so we will implement option B, open addressing. Now what is this open addressing? So open addressing is we are generating a new index number when collision occurs. So generating a new index has different ways. So the way which we are going to follow in this code is linear probing. So if collision occurs at index I, then we are going to look for the array slots I plus 1, I plus 2, etc. Like until we find the any vacant slot. Okay. So let us start with our class hash table. Alright. Now define init. So in our init method, first we are going to declare some variables, right? So self dot capacity. So it's going to, let's say capacity is 4 initially. Okay. Now capacity will be the total number of data that can be stored. Okay. Now self dot keys equals to, we are initializing a list, and it's going to contain as many none in our code as the capacity, right? So self dot capacity, so it's going to contain as many nuns as it has the capacity. So self dot values also, so again as many nuns as there is the capacity. Okay. So if there are 4, if there is the capacity of 4, then there is going to be 4 none values in both of the R keys. Okay. And now I am going to declare another variable track, self.track. Okay. So initially it's set to 0 to maintain how many buckets are filled, or we can say array slots. Okay. Now we are done with our init constructor, right? Now we are going to define hash function. Okay. So it is going to take a key. Okay. Now hash sum equals to 0. Let me add a comment. This function returns an index value, but and the value is calculated with the help of ASCII values. Okay. So while, sorry, we are going to use the for loop for letter in key. Okay. Or we can say character, right? Now we are going to add ord. Now what is this ord method? So ord method returns the ASCII value. Okay. Now by the time this for loop is done with calculating all the ASCII values, we are going to get a total amount, right? We are going to get a number which is going to be the index value where the data is to be placed, right? But we have to return a value which is in the limits of the index values of our list data structure. We don't want to end up giving an index error, like index out of bound error. So we are going to use the mod operator, and it's going to take self.capacity. Why we have done this? To avoid index out of bound error. Alright. Now this hash function is completed. Now let's start with insert method. So it's going to take a key and some value. Okay. Now before writing the code to insert a new data, we want to check if there are any vacant array slots or not. So if self dot track equals self dot capacity, print array full. Alright. Now we are going to use index variable. We have declared a variable and it is going to take self dot hash function, and it is going to pass a key. So we are passing a key to our hash function which we have declared, and the index variable is going to store an index value, right? Now while self dot keys index. So what does this line mean? So while key exists or is not or none. Okay, so if self dot keys index equal to the key which is provided by the user, we can just update the value associated with the key, right? So self dot values of index position equals to the value given by the user. Now index equals index plus 1, and again we are going to use the mod operator, and again to avoid index out of bound error. Alright. Now when the loop finally terminates, it means it has found a vacant space, right? So we can uh, update or just add new entries. So index equals key and self dot values of at index position equals to the value, and finally self dot track is incremented by 1 because we are maintaining the track variable, right? Okay, so let us create another function called uh, str dunder, right? And before declaring or defining this method, let me add a comment. We want to print out all the entries in our sequence. Okay, so Python has these dunders. Okay, so we are using dunders. Okay, and it means double underscore, right? So I am declaring an empty string out. Okay, now for item in self dot keys, if item, so if true, it means if item is not a none. So if it's not a none, we are going to add to this string an if statement which says item. Now self dot values and self dot keys dot index item. So this self dot keys dot index, and in the bracket I have passed item, so it is going to return an index value which will be passed into self dot values, right? So it is going to fetch the value at the index position which is returned by self dot keys dot index item, right? And we are going to use a slash n for new line. All right, okay, so when the loop terminates, it is going to add all the entries in our empty string, right? So now we are going to return out, but before returning, it is going to strip out the last most new line variable. Okay, new line character is going, because that's not required here. Okay, so equals main. Oh, sorry. Okay, so in the next video we are going to test our code and write some more methods like remove method and get method. All right, so see you there.